Hi guys, welcome to Pepcoding. So in this video we are going to discuss another new question of arrays in string series, that is my segmented sieve. So in this question, in segmented sieve, you have to print all the prime numbers between a and b, where both a and b are included. So you have to print every new number in every new line, and the allowed time complexity is order of n log n, which is familiar to us because we have solved our Sieve's algorithm before. So we know how to solve in order of n log n time. Alright. Now allowed space complexity here is order of n, where n is equals to b minus a. Alright. Okay. So now let's discuss how we are going to solve this. So suppose given to me a is my low and b is my high. So the first approach that comes to my mind is what? First I will call it approach 0. So approach 0 says that print all the prime numbers from a to b, generate all the prime numbers and print them in new line. So it says generate all the prime numbers between a and b and print them in new line, right? But this is going to take order of n root n time, because for every number we run a loop till root n time and we have n numbers, so its time complexity is going to be n root n. So now I am approaching to my next approach, that is my approach 2. Approach 1 says generate prime array using Sieve. Prime array using Sieve algorithm. But in Sieve we generate, like we are given, we have to generate prime number from 2 to our upper range. Upper range is n, it can be any number, but my lower range is fixed, that is my 2. And we create an array of size b, that is my upper range. We create an array of size b. So here the constraints are a lies from a to b and b is in between a to, like b is from b to 10 raised to the power 9. So suppose if my b is 10 raised to the power 9, then I have to create an array of 10 raised to the power 9, right? Which is not allowed. We cannot do so. So here the second constraint that I have is that my b minus a is less than equals to 10 raised to the power 5. Okay, it says its difference of my lower range and my upper range is 10 raised to the power 5. So I am going to use this second constraint. Okay, now let's approach to our third approach. Okay, that we are going to do. We are going to solve here. Okay, so my third approach, I call it approach 2. Okay, so let's see what does it says. Let's see, suppose my a is equal to 22 and my b is equal to 51. So I am going to make an array of size b minus a plus 1, right? Because it is considerably less than 10 raised to the power 5. Okay, so I am going to make an array of this type, b minus a plus 1, this size, and I am going to generate all the prime numbers till root b. Why am I considering root b? Because till root b I find all the prime numbers till b, right? And after that I am going to have if I am having a into b, right, this kind of combination, and after that, after root b I am going to have this kind of combination, b into a. These all are my combination, right? So I am just considering my prime numbers till root b only, right? So because after that it is going to be a combination of my prime numbers. Suppose this root b is equal to 7, so till that I have prime number 2, 3, 5, 7. So after that all my numbers, let's say my initial number I consider 24, that is between a and b. So its vectors are 12, 2, 6, 4 and then 3, 8, right? And after that okay, this much only, and 4 into 6. So after this number I am going to have a combination, right? 4 into 6, then 8 into 3 again, then 12 into 2, 2 into 12. So this is just a combination after that. Alright, where places are interchanged. Okay, but my prime number is this 2 and 3, right? Because till root 24 I have prime numbers. I am going to have prime numbers 2, 3 and my 4. And my 4 is not a prime number, right? Okay, so this prime number till root 24 I am going to have these two prime numbers, and after that I am having my combination. Okay, so this numbers generates all the combination, that is 3 is here, 2 is here. Okay, so it will give me the multiple of this 2 and 3 will give me the multiple of 24 even after this also, right? Okay, that's why I am considering my numbers 2 till root b. Okay, now what is going to be my b minus a? Let's discuss what will be my size of my array. So b here is 51, b minus a 51 minus 22, which is equal to 29 plus 1. So my array will be of size 30. Okay, my array will be of size 30, which will be of type boolean. So here in my boolean array, 2 represent non-prime number and my false represent prime number. Alright, okay, so here let's generate number till root b, that is equal to till root 51, 2, 3, 5, 7. These are my prime number. Sieve algorithm will give me the array list of this prime number. Now let's make an array of size 30. So it will be of this type: 2, 3, 4, 5, 6, 7, 8, 9. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay, now this number of what will be the number at this index? At this index I will be having my a plus I. So a is 22 plus 0 is 22 here, because at index 0 my lower range number, the number at my lower range is going to be there. Here 22 plus 1, that is 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51. Okay, now I take 2 here, that is my prime of I, prime of 0, let's say prime of I is 2 here. Now I will mark all its multiple to be true. So 22 is a multiple of, let me take another, 22 is a multiple of 2, I marked it true. 24, 26, then 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. Alright, after that multiples of 3, multiple of 3 is 24, which is already marked true. 27, and then 30 is marked true. 33, after that I have 36 is marked true. 39, 42, 45, 46, 47, 48, then 51. Alright, multiple of 5, 25, 30, 35, 40, 45. Multiple of 7, 42, 28 marked true, 35 marked true, 49 marked true, right? 42 is also marked true. Okay, the remaining number are 23, 31, 29, 37, 41 and 43 and then 47. These are my prime number, that is 23, 29, 31, 37, 41, 47 or 49, 43. These are my prime number. Okay, so now if I have to mark 3's multiple true, right? If I have to mark 7 multiples true. Then I have to check from where do I have to look into my array, because I cannot start from index 0 again and again for every prime number. So I have to check the starting index from where the multiple of 7 start. Let's say, okay, so now the multiple of 7 is 28. Okay, so I don't have to look to 22, 23, 24. I should start from 28. That is from 6th index, right? So just to calculate my starting index, it can be for this 5, because the starting index for 5 should start with 3. That is, and for 3 it should start for 24, right? So now we'll discuss how we can calculate my starting index. Okay, my starting index. Now how can I calculate my multiple? So first of all, I will calculate my multiple, which will be equal to my smallest value multiplied by 1.0, because we are going to take seal here, so I multiply it with 1.0 and then divide with my prime of I. Okay, let's say my A is 22 multiplied by 1.0 divided by 7. So it is going to give me some 3 point something value. I take its seal, which is 4. But still I have found my multiple only, not the starting index. Now for starting index, what can I do? My multiple, that is my 4, multiple multiplied by my prime of I minus my starting value. So multiple is 4 multiplied by prime of I, which is 7, minus 8. 28 minus 22. It is going to give me 6, and at index 6, as you can see here, at index 6 we have 28, right? So for 7 I have to start from index 6. Now take for 5. If I see for 5, if I take an example of 5, so 22 multiplied by 1.0 divided by 5, it is going to give me 4 point something value. So it gives me 4 point something value, it will become 5. Now 5 multiplied by prime of I, which is equal to 5 multiplied by 5 minus 22. 25 multiplied by 22, which is equal to 3. So here, as you can see, at index 3 I found my multiple of 25. Starting index of my multiple of 5, which is equal to 25, right? Okay. Now here comes a problem. Sorry, there is a subtle test case that can be failed. So we'll discuss it now. Let's say my A is equal to 2 and my B is equal to 100. So my array would be like this. At 0th position in my array, I will be having 2. 1 position will represent 3. 2 position will represent 4. 3rd position will represent 5. This way up to 100, right? So from here, as suppose I have A is equal to 2. So if I calculate multiple for this, so 2 multiplied by 1.0 divided by 2, because prime of I is 2 now. 2 here, because my array is this type. These are my prime numbers, right? So my prime of I is 2. So if I calculate for 2, it is going to give me a multiple of 2. Now if I calculate its starting index, so SI will become equal to what? Multiple multiplied by prime of I, which is 2 minus A. So 2 minus 2 will give me 0. So if I mark this position, that is at starting index, that is at index 0, if I mark this 2 as true, it is going to lose a valid prime number, right? So whenever I get my multiple to be 1, I have to increase my multiple to multiple plus plus. Alright, if I do so, if I keep my multiple plus plus here, so my multiple become equal to 2. So now my starting index will become equal to 2 into 2 minus 2, which is equal to 4 minus 2, which is equal to 2. So which is at next multiple of 2, which is equal to 4, right? So that's why whenever I found my multiple to be 1, if multiple is equal to 1, increase it to be multiple plus plus. Okay, all right. Now we have discussed like what do we have to do. First of all, we have to make an boolean array of b minus a plus size. Then we have to ask Sieve method to give us the prime numbers, right, till root b, and after that we have to mark them true by calculating the starting index up to array dot length, right? Okay, so let's write some code now. First of all, this is my segmented Sieve algo. I will be making a string here, string answer, which is equal to empty string initially. Now I am going to make a root b variable, which is equal to square root of sqrt of my b, right? Square root of b. Okay. Now what do I have to do? I will make a vector of boolean type, vector of bool type, bool arr, which is of size b minus a plus 1, right? And a vector of type integer, which is going to be my answer. So which is going to take prime number. Prime is equal to sieve, sieve of this, right? And then I'm going to pass root b here, because I have to calculate prime number till root b, right? Now we'll run a for loop for int prime number in my prime. Okay, what am I going to do here? I have got an array of vector containing all of my prime numbers, so I am going to calculate my multiple here now. Multiple. So int multiple will be equal to what? Seal of multiple, sorry, a, that is my lower bound, multiplied by 1.0 divided by prime of I, that is equals to my prime number, divided by prime number. Okay. Divided by prime number, it is going to give me a multiple. Now I'm going to check if my multiple is equal to 1 or not. If my multiple is equal to 1, then what am I going to do? I will increase my multiple to my multiple plus plus, and after that I am going to calculate my first index, which will equal to multiple multiplied by my first index, sorry, multiple multiplied by my prime number minus a. I get my first index. Now I will start from my first index for int I is equals to f of I should be less than my arr dot length, sorry, dot size, arr dot size I plus equal to my, sorry, we are not going to run a for loop, we will use a while loop here. Let me use a while loop here. While fi is less than arr dot size, I will check if arr of fi is equal to false. If it's a false, this is my first index, sorry, I am going to make arr of I as false, sorry, true. I am going to mark it true, because this is my first index, and then I am going to increase my first index to equal to prime number, right? I have marked all its multiple to be true, right? Okay, now I will make a vector of type integer, which will contain my answer. Now I will run a loop for int I is equals to 0 to be less than arr dot size I plus plus. If arr of I is equal to false, it means it's a prime number, and if it is a prime number, then append it to your answer. That is my string answer plus equal to 2 underscore string a plus I plus, let's convert it into a string, 2 string. Okay, so here 2 string a plus I plus underscore backslash n. Okay, now again answer plus equal to backslash n, then see out answer, see out my answer. Okay, now here I will be having one more condition here, that is if my a plus I should be greater than 1. It should be, why are we checking a should be greater than a plus I should be greater than 1? Because a is my lower range, it cannot be equal to, its sum with sum I cannot be equal to 1 or less than 1, because if this sum is less than 1, it means my a is even more lesser than 1 or maybe equal to 1. If I put I to be 0, then my a is equal to 1, right? So if my a is equal to 1, it means a is not a prime number. So we should check if, because my prime number starts from 2, so we should check if my a plus I is greater than 1. Alright, so here we'll check if a plus I is greater than 1 or not. Okay. Alright, now we are going to write our this method. This is my sieve method. Okay, so here also I will be making a boolean variable, bool type array, which will be of size n plus 1, n size. This is my boolean array. Then I will be making a prime vector of type integer, which we have to return. Now I will be running a loop for int I is equal to 2, I into I should be less than equals to my capital N I plus plus. Alt int I is equal to 2, I multiplied by I should be less than equals to capital N I plus plus. Okay, now I will check if my ARR of I is it, if it's false, then it's multiple or also false. Then I will run a loop for int j is equal to 2 into I, where j is less than equal to capital N j plus equal to I, plus equal to I. Alright, if it's, then we have to mark it true. ARR of j is equal to true. Alright. Okay, now we'll be making an answer vector of type integer. Sorry, we have made an answer which is prime here. Okay, now I am going to run a loop, for loop for int I is equal to 2, I should be less than n, less than or equal to n, I plus plus. I will check if ARR of I is equal to false. If it's false, then it means it's a prime number. So prime dot push underscore back, push back I, and then return prime. Okay, now let's try to run this. On line 27 there is some error, int root v int square root u. Okay, let me check. And at line 27, okay, let's see what do we have to do here. यहाँ पे error है, this b should be in parenthesis. B should be here in parenthesis, and then at line 27 it should be in parenthesis. In 34 it should be CEIL, seal. In line 39 ARR dot size will have parenthesis. At line 45, okay, we have declared answer, string answer, alright. And at line 46, okay, now let's try to run this. sorry. Okay, so here the size of a prime ARR my boolean array will be n plus 1, and here we have to write this in curly braces. So this was the mistake only. Now let's try to run this. Okay, successful, and now let's try to submit this. There is some problem again. Let's see. Okay, so here it should be a parenthesis here. Yeah, there should be a parenthesis here. That was creating a problem. Now let's try to run this. Sorry, submit this. Okay, submitted. So this was all about my code. Now let's discuss about time complexity. Okay, time complexity of this code.